In this video, I would like to review the concept of probability, expected value, variance, and a standard deviation. Let's think about a stock. It can give you 2% return, 5% return, 12% return, or 8% return. For each one of these outcomes, there is a probability number associated with it. For example, let's say this 8% return. There's 30% of chance for you to see 8% return, right? Of course, for stock, it should have also negative returns, right? Otherwise, of course, we will purchase it. So there's always some chance for you to lose money in purchasing stock, but let's stick with this example. These probabilities for the four outcomes, let's say these four are all the possible outcomes there are for this stock, okay? All of them, nothing else. Then you sum them up for these probabilities, you sum them up, it should be equal to 100% or 1, okay? So all the probabilities sum up should be 1. It can never be larger than 1. Okay. Then we want to know, if I purchase this stock, what I should expect? What's the so-called expected return? Or say, let's calculate the expected value of these random returns. Okay? Now, how do we do that? Basically, we want to use the probability to weight each outcome, and then we sum them up. So we kind of have a weighted average, and the weight is the probabilities. Okay. Here we just use column A times column B, and that's exactly how I weight this 2% outcome, right? And same thing here is 30% times this 5% outcome. Then 30% times the 8% outcome, and the 20% times the 12% outcome. You sum them up. Again, using this summation SUM function in Excel, you will get 6.7%. That's the expected return for this stock, or say the expected value of all these random returns. Okay. So far we have reviewed the concept of probability and the expected value. And let's think about the deviation. The deviation is for each outcome, this 2%, okay, how much it deviates from the expected value. So here I have 2% minus 6.7%, the deviation is minus 4.7%. Let's take another example. If I got 12%, right, the deviation from this expected return 6.7 is plus 5.3%. It's a positive deviation. Okay, because all these deviations are either positive or negative, if you weight them with the probabilities and sum them up, you will get 0 for sure. Right? It's mathematically that's the result. Okay, so we cannot simply sum them up. What do we do? We have to take the square of them, and then we weight them with the probability. So you can see here I first square the green number, this negative 4.7 here, and then times the blue number here, probabilities. Okay, so I square them one by one time with the probabilities. Again, I use the probability to weight all these squared deviations, and then I sum them up. That's the variance of all these different returns, right? All these random returns. But you can see this variance is not really in the same unit as either the expected return or simply all these random returns, because I squared them. So to make them, make this number in the same unit as this expected returns or the random returns, I need to kind of scale it back by taking a square root, right, to the power of a half. And then I take the square root. I got a so-called standard deviation. Is the square root of the variance. And now you can see the standard deviation is 3.38%. It's in the same unit as this random returns or the expected returns, right? The variance itself is 0.1% something. It's too small to figure out. Yeah, you can tell me the variance, but exactly how do I know where the random returns lies around the expected return, right? Or say the random outcomes, how the random outcomes lies around the expected outcome. Now the standard deviation on the other hand are in the same unit as this expected outcome or the random outcomes, so I can know actually if, let's say, I use the expected return 6.7, right? Let's use it plus 1 standard deviation. It's about 10%. Now it's really between 8% and 12%, right? It's kind of tell me where things are. And let's say again use this expected return minus 1 standard deviation. It's about 3%. Exactly between the 2% and 5%. Again, expected value minus plus 1 standard deviation kind of tells you where the outcome will be. Or basically we say if you use the expected value plus minus 2 standard deviation, give you about 95% of all the outcomes you can possibly get.